I mean,
I don't know. This is good to be information.
Yikes! I was gonna say Brooklyn.
Schools over there now, like using your videos.
I'm sure. I am 100% sure that's exactly what's happening.
You're probably famous. They're gonna change the language.
Famous in China.
This is what the Westerners do.
It's what they do to practice their English. Oh, perfect. Okay, so we are talking about today exponents that are fractions. Okay, so we got to do a little bit of background review, and it should be a review. I looked up the things. I was like, I wonder if they've done this before. You need to sit up and pick it up. If you sleep again, I will send you to the office. So I want to talk about this symbol. Do you guys know what that means? What is that called? It's just called a square root. Okay, so a square root, like the square root means it's asking you what times itself is 25. So what squared is 25? 5. And so do you see that square roots are related to exponents? Okay, so the square root, the square root of 25 is 5 because 5 squared is equal to 25. Okay, so what about the square root of 9 then? 3. Okay, now, how about the square root of 100? Yep. Now, there is something also called a cube root. Okay, a cube root. A cube root is what times itself 3 times, something cubed that equals that number. So we'll see if you can come up with this. And if you need your calculator to guess and check, that's fine. Okay, so what times itself, so 3 times is equal to 64. Yeah, it's 4. 4 times 4, 16 times 4 is 64. Okay, and we know that's because 4 cubed is equal to 64. So how about the cube root of 8? Yep. Are you cheating? Ah, this is 2. Okay. So those, we can have roots, you guys. We can have roots that go all the way up. We could do 4th root. Okay. We could do 4th root of 16. 4th root of 16 is 2.
Somebody out there.
No, but put it on the thing still. Oh my God. It's okay.
Okay, so here's what I want. Like, this is background information. This is background information. So what I would like you to do in your calculator is do 25 to the 1/2 power. Same spot.
That makes sense.
Okay, so remember that your calculator has a caret key. That's the guy above the division. It's called the caret. Okay, so 25 with the caret key, and then do the fraction and do 1/2. Okay, just like that. And you should get 5. You can do 0.5. I'd actually like you to keep it as a fraction, though, now that I think about it, for what's coming. You could, but we're doing other stuff with it. Okay, I'd like you to do 9 to the 1/2, please. 9 to the 1/2. Okay. 9 to the 1/2 is 3. Now I want you to realize it's not half of 9. Okay, I want you to try 1/2 Nope, sorry. 100 to the 1/2 power. Owen, what'd you get?
I got 10.
10.
I got 7. I got 7.8888095. Oh.
Okay. So let me ask you this question. You should see some stuff up here related to what we're doing. So what do you think 16, without using your calculator, 16 to the 1/2 is?
4.
4. Same thing. Because, okay, here's what we want to know. A 1/2 power, and this I want you to write down, is the same as a what? Square root. Okay, a 1/2 power is the same as a square root. Now, what do you think? So well, let's see, let's go this way. I'd like you to do in your calculator 64 to the 1/3 power. Okay, 64 to the 1/3 power is 4. Okay, try 8 to the 1/3 power. 8 to the 1/3 power is 2. So 125 to the 1/3 power? 5. Now, here's my question. A 1/3 power is the same as what? Yeah, cube root. Okay? Like that guy. He's called a cube root. Okay, square root looks like this, right? Cube root looks like that. So the 1/3 power is the same as the cube root. So look at what we had written down as far as review. Without using your calculator, what do you think will be 16 to the 1/4 power? It's 2. Because 1/4 power is the same as the 4th root. Okay, 4th, that's a 4, 4th root. Okay, this is a 4th root. Okay, so here's my question. Okay, here's my question. What if I asked you to do the 5th root of 32, but write him as a fractional exponent? What would his fraction be? He would be 32 to the what power? 1/5 power. Right? 1/5. So, do you see the relationship here? Whatever the bottom of this fraction is, see if I can point it out to you. This guy here matches the root. So if this is a 5th root, it's a 1/5 power. So we're going to write that as a general thing. Okay. So the nth root of x, so that's what we call that, the nth root, because he's just a number, would be equal to x to the what? 1. Well, listen, 1n would look like that.
X to the first power. So just n.
Where is the, okay, look. Where is the 4 here? It's on the bottom, right? This is a 3 and it's a cube root and it's on the bottom. This is a square root, and the 2 is on the bottom. This is the 5th root, and the 5 is on the bottom. So this is going to be x to the what?
1n. 1 over.
There you go. 1 over n. So the nth root of x is x to the 1 over n.
You can have 0.
Yep. So if I asked you to rewrite this, what would the 6th root of x be? What would the 6th root of x be rewritten as?
X to the 1 over 6.
X to the 1 over 6. Okay? Now, I want you guys to do this one quietly to yourself. I want you to write down what would the 8th root of p be equal to with the fractional exponent. Yep. Flip the red thing. Okay? This would be p to the what, Charlie? P to the 1 over 8. Guys, this is the first half of your homework, to go back and forth between these two. Okay? We're not even close to done. Okay? Well, I don't, probably not. It'll probably be tomorrow. Okay? How about this guy? Okay? Quietly, don't steal anybody's learning moment. I want to know what this would rewrite as. Okay? This would be x to the what? 1 over 9. Gabe, we're not doing anything on their calculator right now, so I'd like you to put it down and pay attention, please. Okay? Now, what if I asked you to rewrite the other way? What if I said this is y to the 1/3? What would he be equal to? Cube root of y. Correct. So you guys, you say this cube root. So square root is square root, cube root is cube root, and then it's 4th, 5th, 6th, 7th, and on up. Okay? That's how you say it. This is how you write it. But look, this is what I want you to see. This and that always match. The thing on the bottom always matches the root, and it's easy. Like, if you're, so let me say this. I don't want to, this is not a judgy statement. If you're feeling like this is difficult, relax your brain a little bit. It's not supposed to be. Okay, it's literally this 3 goes here, and it goes inside that rooty symbol. That's called a radical, by the way. So let's do z to the 1/12. Okay, z to the 1/12. Okay, what do you think you're gonna call that guy?
Z to the 12th root.
12th. So 12th root. That's weird, but did you say 12th root of z? 12th root of z. So z on the inside. It's just a rewrite. They're the same thing. We're just rewriting them. Okay. Do you have any questions on that? Okay. Now, what I want you to do. Now we're going to combine a couple things here. So this gets a little bit weird, but if you pay attention, you're going to be fine. Let's say we have, let's go 8 to the 2/3 power. No, I don't like that. Let's go 8 to the, no, we're going to go, 27 to the 2/3 power. I'd like you to put that in your calculator. Okay, so 27 with the caret and the 2/3. Nine. Should be 9. Okay. Let's do, let's do 9 to the 4. No, sorry. Let's do 8 to the 4/3. That's a really ugly 8. 8 to the 4/3. 16. Let's do, this is the one I wanted. 9 to the 3/2. 27. Okay, so let me tell you what these guys are doing. Okay, we're also going to talk about rewriting this. This is two things happening. So when you have a number on the top and a number on the bottom, two things happen. So this 27 with the 2/3, if there's a 3 on the bottom, we know that there's what? What does that rewrite to? Cube root. Yep. So cube root of 27, like we know that's part of it, but it's also squared. Okay, so this 2 is on the outside. This 3 is the cube root part. So what I want you, no, I don't want to do that. Okay, so 27 cube root and then squared. So the cube root of 27 is 3. Because 3 times 3 times 3 is 27. And then you do the 3 and then you square it and you get 9. Okay, so that's what it's doing. It does, your calculator does the cube root first and then it does the top. So this guy would be the cube root of 8 and then to the 4th power, like that.
Do you put it in the parentheses?
No, I'll actually tell you something about that just a second. I would put it in parentheses, just looks neater. So what is the cube root of 8? It should be in your notes. I think we already did that one. It's at the very top. What's the cube root of 8? 2. And then 2 to the 4th is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. Okay, so 2 to the 4th is 16. Now, do you need to understand that all the way? No, but you do need to be able to rewrite them. Okay, so I'll show you this one also, and then I'll show you how it works one more time. 9 to the 3/2 would be, the bottom is the root, so square root of 9 to the 3rd. Now, here's the deal. This is kind of what I was going to say to Sawyer. You can actually put the 3 on the 9 if you want, or you can put it outside the 9. So you can either do it with the parentheses like this, or you could do the cube root of 9 to the 3rd and put the 3rd on the inside. So it can be on the top, it can be outside, it can be inside the square root or whatever. Okay, so let's practice this with letters first, I think. So let's say we have x to the 7/2. X to the 7/2. So I want you to remember, the bottom number is the root. The top number is just an exponent. So I'm going to write this guy, square root, which does not have a number, right? Doesn't have the 2 on there. Square root is just a naked root. I said naked, that's weird. And then x, and then the 7 is the exponent. So just pop the 7 out there. Okay, or you could go, this is x to the 7th, and put the square root on the outside. Both of these are acceptable and correct. And I would give you credit on a quiz for them. Okay, I think on your homework, when you have it, you'll have it both ways. So let me check. Yeah, you do have it both ways on your homework. Okay. So let's try this one. Let's say we have m to the 4/3. Okay, this one you'll be able to see better where the numbers are going. M to the 4/3. Okay, first of all, what root do we have?
The fourth.
Nope.
Third root.
Cube root. Bottom is the root, right? And then it's m with the 4. So 4 on the outside or 4 on the inside. Just like that. Okay, we're going to do one more and then give you a formula, and then we'll practice this some more. A formula. It's kind of a formula. Let's go y to the 2/5. Y to the 2/5. Okay, so what root do we have? 5th root. Okay, y and then what? 5th root y squared. Okay, so you guys, really this is a matter of remembering that the bottom number in the fraction goes with the root and the other guy just hangs around, either on the outside or the inside as an exponent. So let's say we have x to the m over n. So this is like the formula part. If I have x to the m over n, what's the root going to be? N. And it's going to be x to the m, like that. Or I can have n and x to the m on the inside. Okay? So all this does is show you where the things go, right? This is, so don't freak out. I know it's a lot of letters and it looks weird. All it's doing is showing you bottom number is the root. Top number is going to hang out up here or over here. That's all that's showing you. Okay, so don't let it freak you out. I think if you were absent and you were like, what the heck? You would be a little freaked out, but it's not hard. So let's say I give you, let's go the other way. So let's say I gave you the 5th root of x to the 4th. The 5th root of x to the 4th. I want you to rewrite him with a fractional exponent. Okay, he would be x to the what? 4/5. 4 over 5. Because the bottom, this guy is the bottom of the fraction. Okay, that's it. So then, let's do the 9th root of z to the 11th. 9th root of z to the 11th. Please rewrite him with a fractional exponent. Okay, so this would be z to the what? 11 ninths. Z to the 11 ninths. Okay, let's do one more and then we'll talk to you about a couple things. So let's say I have the square root of p to the, let's go p to the 12th. The square root of p to the 12th. Bless you.
What if you can simplify?
Good question. That's why we did this one. Okay, so if we rewrite this as his fractional exponent, it's p to the what?
12 over 2.
It's 12 over 2 as a fraction, but if you were listening to what McKinley said, by the way, you guys, it's learning from other people's questions is a great idea. This would actually be p to the what?
6.
P to the 6th, because it reduces. because 12 divided by 2 is 6. Now, I got good news, I got bad news. Bad news is that your book thinks we should just be like, hey, all those exponent rules that we just did in the first part actually apply to all of these. So you should be able to add and subtract fractions and multiply fractions and all that. The good news is we're not going to do that. We're skipping it. So tomorrow we will finish this lesson up. We'll practice this with some numbers, and then we'll have homework time, and we'll actually probably be done in enough time to go on to the next lesson. Yep. So exciting. Please put your calculator back